4.4, write linear equations in standard form. We've already touched on this a little bit. Standard form is ax plus by equals c. We want to make sure that the a value, so a must be positive and a cannot be a fraction. That would be considered standard form. Example 1, write two equations in standard form that are equivalent to 2x minus 6y equals 4. Write two equations that are equivalent. Write two equations that are equal to 2x minus 6y equals 4. So, what could I do to this equation, the first one? What could I do to 2x minus 6y equals 4? Well, I could divide all the terms by 2. I see that I can divide a 2 out. So 2x divided by 2 is x. Negative 6y divided by 2 is negative 3y. And 4 divided by 2 is 2. So we just divided all the terms by 2. Here's one answer, which is the most simplified answer. This problem is not reduced. What else could I do to this equation to get another equation? There's an infinite number of answers here. There's only one thing I could do to reduce it down. Well, how about multiplying something to it? I could multiply the entire equation by 3. So when I'm multiplying 3 to everything, that means I'm distributing that 3 onto the entire equation. 3 times 2x is 6x. 3 times negative 6y is negative 18y. And 3 times 4 is 12. Here is a second possibility. Again, there are an infinite number of ways to create this equivalent equation. Write an equation in standard form of the line shown. I have a line, and I need to write an equation in standard form. So we know we're looking for ax plus by equals c. Well, what's the given information? What do I have to write an equation of a line? I have 2 points. So what can I do with those 2 points? We're going to start by number 1, finding the slope. So we're using the points 1, 1, and 2, negative 2. Subtract our y values, negative 2 minus 1. Here's our y values. Negative 2 minus 1 divided by 2 minus 1. And we get negative 3 divided by 1. So we know that our slope is negative 3. And I'm going to continue to write an equation. I think that I will use the point slope form. So I'm going to choose the point 1, 1. Y minus y1 equals my slope times x minus x1. Y minus y1, my y is 1, equals my slope of negative 3 times x minus x1. Can I leave my equation in this form? This is point slope form. Everything's simplified. I'm done. The direction said standard form. We need to keep simplifying. So negative 3 times x is negative 3x. Negative 3 times negative 1 is a positive 3. All right. So I need to think about standard form and how my a value needs to be positive. Looking at my x term, and I need that coefficient to be positive. So I look at my equation here. Is my a positive? It is not. That means I would like to put my negative 3x on the left-hand side to make it a positive 3x. And at the same time, I'm going to shift the negative 1 over to the right-hand side. So I'm going to add 3x. And I'm also at the same time, so these cancel. At the same time, I'm going to shift my number over to the right. I could do it in 2 steps, but I'm kind of running out of room here. So I'm going to add 1 and put that over here, and those cancel. So I'm left with 3x and a positive y. We have 3x and a positive y equal 3 plus 1 is 4. Standard form. My a value is positive. I have my x and my y together on the same side of the equation. My c term is on the right-hand side. Write an equation of the specific line. So it doesn't ask for it to be in standard form or slope-intercept form or point-slope form. It just says write an equation of a specific line. Blue line, red line. Here is the red line and the blue line. Well, what kind of line is that? Does it have a slanted slope? Does it have a negative slope? Does it have a positive slope? And it does not. These are horizontal and vertical lines. And we talked about these lines back in the previous chapter. If you Hoyavux, we have vertical lines, which have undefined slope, and they cross the x-axis. So a vertical line that's crossing the x-axis, here at -2, it's crossing at -2. Therefore, the equation was x equals -2, the equation of a vertical line. A horizontal line has 0 slope, and it crosses the y-axis. So here we have a line that's crossing the y-axis. It's crossing at 3, therefore the equation would be y equals 3. So looking at these lines, we want to write an equation. And can we tell where it's crossing the axis? Let's see here. This is at 1 and -1. That's 1. So this would be 2, 3, 4. And that would be the 0.41, so that matches. And then checking going down, is this -1, -2, -3, -4. So we have the 0.2, -4, and it does line up. So those should be pretty easy to write. The blue line is a horizontal line. It's crossing the y-axis at -4. So that would be the horizontal line, y equals -4. The red line is a vertical line, and it crosses the x-axis at 4. So that would be x equals 4. Here's some algebra. Find the missing coefficient in the equation of the line shown. Where is the equation of the line shown? We see an equation here. What form is that in? It's in standard form. Find the missing coefficient. It looks like we're looking for a. So we have an equation of a line. Find the missing coefficient in the equation of the line shown. Write the completed equation. So how am I going to find a? How many variables do I have in this problem? I have a, I have an x, and I have a y. That's 3 variables. I need to have an equation that has less variables so that I can solve for that leading coefficient. Is there anything else in the problem that's been given that I haven't used yet? Anything else in this problem? I see that I also have a coordinate here, -1, 0. Can that help me? What does -1 stand for? What does 0 stand for? That would be x and y. Oh, I know what x and y are. Here's an x, here's a y. If I substitute that in, that would leave 1 variable to solve for. All right, we're going to substitute in our x value. So we have a times x plus 3 times y equals 2. So my x is -1 and my y is 0. Ooh, how convenient. All right, a times -1 is -1a. 3 times 0 is 0, so there's nothing left there, and then we have equals 2. My a is not positive, so I still need to continue solving for a. -1 is being multiplied to a, so I can divide by -1, divide by -1, and I get positive a equals 2 divided by -1 is -2. Yay, I'm done. Write the completed equation. Do I stop here or do I continue? I need to write the completed equation. Now that I know what a is, I need to substitute in a. So I have -2x plus 3y equals 2. There is the completed equation. Am I really done right now? Is there anything wrong with this equation? We see that a equals -2, and we're not supposed to have a negative for our a. I need to finish this problem. What I'm going to do is I'm going to multiply this entire equation. I'm going to multiply by -1. Multiplying by a -1 will change the sign of that first term. So our completed final answer is -1 times -2x is a positive 2x. -1 times 3y is -3y. And -1 times 2 is -2. Now I see that I have my completed answer. My A is positive. Your class is taking a trip to the public library. You can travel in small and large vans. A small van holds 8 people, and a large van holds 12 people. Your class could fit 15 small vans and your class could fill 15 small vans and 2 large vans. Write an equation in standard form that models the possible combinations of small vans and large vans that your class could fill. Graph the equation from part A. List several possibilities here, possible combinations. We have 8 people in the small van. And we have 12 people for the large van. And altogether, your class could fill 15 small vans and 2 large vans. So 15 small vans, and that's times 8 then, because a small van, so times 8. And then 2 large vans can hold 12 times 12. So how many people altogether then? 15 times 8 and 24 for this. So we know that the total amount of students then would be 144. So 8 people in the small van plus 12 people in the large van, and the total number of people is 144. So this is S for the small vans, and this is the L for the large van. So S and L, like X and Y. And right, let's look at if the large van didn't have anybody in it. How many would the small van have? We have 8S plus 12 times 0 equals 144. So we're looking at if the large van doesn't have anybody. Plugging in 0 for the large van. And we get that 8S equals 144. So divide by 8. And the small van would have 8 into 14 goes once, with 6 left over, and 8 into 64 is 8. So 18. You could have 18 small vans. How about if there were no small vans and it was all large vans? So we're going to do 8 times 0 plus 12 large equals 144. 8 times 0 is 0, so we have 12L equals 144. Divide by 12, and we get that the large vans we could have 12 large vans. This was when L was 0, and this was when S was 0. When S was 0, we had 12L equals 144, and we divided by 12 and got that L was 12. So I can graph these 2 points, 18, 0. When S is 18, L is 0. When S is 0, L is 12. There is 2 points that determine a line. We try to be as exact as possible because I'm looking for some other combinations. So there's the corner of the box. And the corner of the box. So we wrote our equation. Let's see, in standard form. We graphed. And now we're looking for combinations. Combinations. So I'm looking for exact combinations. If I look at this line, I see here's a quarter of a box. That means that we could have 12 small vans and 4 large. Are there any other combinations? We could also have 6 small and 8 large. And then let's not forget that we could have 18 small and no large. We could have 0 small and 12 large. Those would all be the combinations. So we might as well put those down. We could have 18 small, 0 large. We could also have 0 small and 12 large. So there are 4 possible combinations for how students could be in the van to go to the library.